Neal Fannin from PennDOT is going to talk to us about chip seals. Neal is a Penn State grad like myself and civil engineering. He's been with PennDOT for over 30 years. Did a little stint in bridge, but is now like the pavement materials kind of guru.
I was asked to do this seal coat thing. Most of the, I assume most everybody has, here is familiar with seal coats. What PennDOT does, I kind of thought I'd go into some of our problems we've had and some of the solutions we've come up with over the last little bit to kind of give everybody the benefit of our experience and go from there. And some of our best practices. What we do mostly, and I'm trying to go a little faster here, mostly is a single seal coat in PennDOT. We do, and this is, I was kind of impressed with this. We do 3,250 average lane miles a year in Pennsylvania. Seal coat, the vast majority of that is done by our maintenance forces. I questioned this number, and Steve Kozer said, yeah, that's it. You can see there we do, District 10 does over 500 lane miles a year, and District 6, which is our Philadelphia district, does like 12. So we have a very wide range of within districts. So that kind of comes out to quite a bit of money, over $34 million I calculated. And I think I was kind of conservative there because I only used a 9-foot roadway width. So in any case, we spend quite a bit of money on this stuff. So in the past, about 10 years ago, we had what you're kind of looking there, a lot, where you'd have the middle come off, we plow it off, and that's generally what we had. And we said, well, that's not quite right. So we kind of figured out that we had a little design error. And this I like to call, this is what our design method looked like up till a little while ago. This is what I like to call the black box of the 1950s. Nomographs, you kind of look at them and you make your little lines and you do your thing and you pick off your stuff. I mean, the older engineers know what I'm talking about. What you're looking at there is that line there, that's the residual asphalt nomograph, okay? And what somebody did was, way back when this was created, they used cutbacks. So a cutback residual is about 75%. The residual asphalt in an emulsion is about 67%, which is the red line there. So we were using this 75%. So when you kind of did all the stuff, we were shorting ourselves 10 to 12% asphalt right off the get-go, which is kind of why we had the problems with our seal coats. Kind of one of them things that we had, and this is kind of where it all started. This road was seal coated. And you can kind of tell, I took the picture on a rainy day, but you kind of tell there's no aggregate left on that road. And it wasn't that it went through a winter and lost all its aggregate. It was seal coated in June and had lost all its aggregate by September. Formed a group and said, hey, what's the matter with this thing? We don't want these things. We're spending $34 million on it a year. We formed this group and we figured out that we did have a problem. With our thing, a lot of people said no, it's the emulsion suppliers, and the emulsions people in the room were involved in it, and we had some of the older guys, and that was great to get the older guys in the room that had been doing it for a while, because what they told us is, well, we just take PennDOT's number and we just add 0.03% of asphalt, per square yard to their designs because we can't get it to stick otherwise, and that's where something's going wrong here. So in any case, full disclosure, we had some problems. Quality seal coat design, you need a quality design to begin with. You need quality aggregates, you need you need to place your emulsion uniformly, you need to roll it. Most that do seal coats roll it more than one pass, because we were only rolling it one pass most of the time. Then a fog seal is a good second chance. We use a modified version of the McLeod from Minnesota method to do our designs. This is one of it. This is kind of the equation that he came up with, and it's a good method. You need the ADT. You can kind of see here. You need the ADT. You need the average gradation for your aggregate you're going to use. You're going to need loose unit weight. You need the type of aggregate, the residual asphalt, and then your surface condition. And if any one of these is really off appreciably, you have a problem in the field, because especially with our maintenance people doing it, we say, oh, you should do the design and then in the field evaluate it and increase if you need to. Well, that really doesn't happen with maintenance, because they have to buy things, and in the field, if you increase the amount you're putting down, you're going to run short. And our maintenance people don't like to do that, So they have to, kind of fudge it a little bit and order a little more than they need, and they don't like to do that either. So you need to get this right to begin with. So a lot of our guys were just going off of experience, and when them people retired, then everybody was kind of lost. They kind of kept it to themselves of what they were doing. So we're trying to go a little more scientific here, and from your maintenance, the state people know that your maintenance people kind of call it an art, and we're trying to get away from that. But the maintenance guys are, they're always going to call it an art. But in any case, here's our new black box, a spreadsheet that we created to help our people do it. On the left side there, you enter in your average aggregate, and it automatically calculates your mean aggregate size, and then you can play around with it a little bit to get where you want to be. Quality aggregate, you need to be clean, hard, resistance to abrasion, cubical. The cubical part is kind of one of them things, we all know you would rather have a cubical aggregate, because on the left-hand side you see the aggregate will lay down and you'll get a flushing type of thing there, but you want a cubical aggregate so it does, no matter what it does, it doesn't lay down. And this is kind of where we went with that. The normal number 8 is on the left, and the more cubical aggregate is on the right. You kind of see there, that's, you're going to have a little better luck with a cubical aggregate. And this is more of a regional thing in Pennsylvania. On a regional basis, you might get pretty darn cubical aggregates. Normal number 8s are okay, but depending on what your situation is, we made it the specification an optional thing that you can specify cubical aggregates if regionally you have an issue. With polymer modified, emulsified, we require polymer modified emulsions unless your DE allows non-polymer modified, which most don't, because honestly the polymer modified will retain the aggregate a whole lot better than the non-polymer modifieds. Uniform coat of emulsion. We've had quite a bit of problem with this. I mean, normally we require the full lap coverage. We get a lot of this where your spray bar is too high and you get the striping, and you can tell when you're going down the road that the seal coat operation had a problem with their spray bar being too high. And then your spray bar is too low. And you still kind of get the same kind of striping, but it's a little wider usually. And you'll get, when you're calibrating, you get this. And so your spray bar has to be right. And then we have a lot of this, a dribble tack type of thing, where your tack truck is simply not set up at all properly. And, that's just a mess. So you can kind of tell here, there's an awful lot that can go wrong with an operation, and our maintenance guys have gotten awful good at it in a lot of most of our districts. And but there's a lot of little moving parts here. Compaction. We have instituted a specification through a lot of back and forth with maintenance that says you have to have more you have to have 2 or more passes between the wheel lines. And what that's based on is basically with seal coats, the wheel lines generally get compacted all right, just from traffic and that stuff. But between the wheel pass, that's about as much compaction or I want to say reorientation as it's going to really see before it gets really set, is the compaction equipment. So we in order to work with our maintenance people, because two passes everywhere, they were really against that, but we concentrated on what was really needed in that. So we kind of came up with that, and you want to reorient the stuff, and you don't. What we were ending up with is the one on the left where you didn't have the compaction in the middle of the lane. We wanted the one on the right there. So, and now we've added a fog seal option, and the fog seal option is kind of your second chance. If we're kind of giving our engineers the second chance at, if you are a little low on what you're happy with your asphalt, the fog seal option gives you that option to put a little more asphalt on there and perhaps save a seal coat that you were going to lose otherwise. Because let's face it, you can't get everything right every single time. So this gives the people out in the field a second option to actually save their seal coat from losing it in the wintertime. And that's okay. Now for something completely different. The seal coat aggregate, we have just recently gotten approved by FHWA a seal coat aggregate from RAP specification. And this came from our District 1 district. They were using, they have piles and piles of RAP material. And they said, well, why don't we, strip out the larger aggregate and use it for seal coat, the number 8s essentially, and we'll have another use for our RAP. And honestly, when I first heard about this, I was like, no way, you can't do that. Here's a road. They kind of ran out of the seal coat aggregate from RAP, so finished it out with a normal. This is a normal beside a seal coat aggregate with RAP. It really has performed very well for us where we've done it. And honestly, it's kind of the way the world's going. We need more uses for our RAP materials. Recycled is just kind of the way we have to start thinking. And so this is just another use for RAPs. This is the gradation. The number 8 gradation. The critical thing here is the 30% maximum passing. What is it? The number 4 sev there, or no? The 4 sev. Yeah. Anyhow, that's really the critical, because what you're looking for is that 1/4 inch stone. You got 60 to 70% that 1/4 inch range type of thing. So that's really what you're looking for. And as long as you really maintain that, your gradation is going to be pretty good for a seal coat. And then you can tell on the lower sieves there, we increased them all, the maximum, by 5%, because honestly it's not that huge of a deal with this. This is what the side by side looks like. Close up, you can tell there's a little more in this of the mid range, the smaller than 1/4 inch stuff in there, okay? Because you're going to get some clumps that are conglomerate, 1/4 inch conglomerate clumps, but it works, and I'll show you kind of a couple little things here. But in putting it down, if you want to try this out, putting it down isn't like a normal seal coat. You need to monitor. The biggest thing is you need to monitor the roadway temperature. If you get above 120 degrees, you need to kind of stop for the day, because you're going to start getting pickup. if you're doing it right, if you're putting enough oil down. Because what happens is the soft pieces start breaking down, and you have less room for the oil to move around, so it starts coming up and sticking to your tires. So that's one thing. And then the wrap, this is just PennDOT thing, is from bullet. The wrap has to be from a PennDOT project. That's just a quality thing. You know that it's the quality of the aggregate is acceptable to PennDOT. And then it's only for lower ADT roads, 1,000 or under. The DE can make it, the district engineer can make it for higher, but we want to stick with under 1,000 ADT for now to see where we end up. But this is most of our roads that we're seal coating are in that range. So this is a picture of putting it down. A little sidebar here. With this, I was on this project, and they had finished one site and were tracking to another site, and they tracked about 5 miles. They just drove their equipment down the road for 5 miles. And you had another thing that's not the same with this material is that they had a little bit of a trouble getting going, because just tracking that 5 miles consolidated the aggregates that were in the auger area, and they had to kind of clean that out before they could really start again, because it had gotten a little clumpy in there. So this is one of them things that you got to think a little harder about. But honestly, it's a pretty darn good use for this stuff. And then another little picture of what it looks like before compaction and then compaction. It's the same as any other seal coat when you compact it. And this is kind of what it looks like when it's finished. You can see it's a little tighter. There, it's a little, it looks a little more like, actually people are really happy with it on their roads because it looks like you paved it. Kind of a nice little product. Making this material, crushing and grading operation isn't terrible, but you gotta kind of, your crusher operator can't just, it's not just a pass it through a sieve operation. You have to, there has to be, he has to get used to it, because it's more of a grinding operation than a crushing operation. It's a little different to make the gradation. This picture is of, we put it under roof. This is in the summertime, so this is our salt building, but we put it under roof because you put it out in the sun, it'll last longer under roof before it starts clumping, that kind of thing. The fines, well, we got about half fines and half number 8s. So if you're going to process a 60,000 ton pond, you're going to get 30,000 tons of seal coat number 8s and half fines. Now, our asphalt industry has not embraced the fractionated wrap process yet. So we struggled a little bit about what to do with the fine material. What we're doing with it right now is we're mixing it about 50-50 with our shoulder backup material and using it like that. I mean, it's the only thing that we really do that has the volume that we need to use up. So, we buy about, it is also benefits the cost of our shoulder backup material. We did a little experiment there, we did that, and then a year later, there's the pile, and it's still fine, it didn't clump up or anything like that. These are just a couple references that I highly recommend. Minnesota has a really nice seal coat handbook, if anybody wants to, look at what seal coats are, and then NCHRP, since this is 342, is another good reference for anybody that wants seal coat. Questions?
Great. Thank you, Neal. Let's give it a hand.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.